Okay, so here we have another electrostatics problem. We've got two charges. Here's one charge, and here is another. Pen is a little bit thick, so let's make it a little smaller. And this charge is going to be a positive charge, and this charge is going to be a negative charge. Now, the value of this one is going to be positive 3.3 microcoulombs, and this one is going to be negative 2.0 microcoulombs. And the distance between them is going to be 21 centimeters. Now, we know that there is going to be a location somewhere that the electric field is going to be 0. In other words, the force on a charge placed somewhere is going to be 0. Where is that place? That's what we'd like to figure out. So the question is, where is the E field equal to 0? Or where is F equal to 0? So the force. Let's consider a few places. Let's consider this location here, somewhere in the middle here. Well, if we put a positive charge, obviously it would be repelled by this charge. Now we've got it. We should call this A and we should call this B. Then we'll know. So the force from A would be repulsive. The force from B, sorry, not that way. The force from B would be attractive. So instead of canceling each other out, they would add. So now we know that obviously it cannot be somewhere in the middle. What about somewhere to the left here? Well, if we put a positive charge over here, this guy is going to repel him, and so A is going to repel him, that's Fa, and this charge B obviously is going to attract a positive charge. So this might look promising. However, it's not. And the reason why it's not is because 3.3 is greater than 2. Therefore, the 3.3 being closer to this charge would be much larger, always in fact larger, than the 2 microcoulomb charge that is further away. Because you see, it has both things going for it. It's bigger and closer. So obviously this is going to be much, much larger. We could do it like this. Much, much larger than this little guy, which is only going to be created by a much further charge B and a much smaller charge. So therefore, I think it's pretty clear that the only place that the answer could possibly lie would be somewhere over here. Somewhere over here, a positive charge. Now, it doesn't really matter if it's positive or negative, but we're just going to contemplate positive. In this case, B is going to attract, and of course, A is going to repel. It's going to be repelled by A. Fortunately, B is smaller, and A is further away, but bigger. So there is the potential, there is the possibility that these two will be able to cancel each other out. Question is, where is this location? So let's call this distance x. And so the distance from here, obviously, would be 21 plus x. Now I'm going to write this in a different way because instead of writing it as centimeters, we're going to call it 0.21 meters. And so therefore this is going to be 0.21 meters plus x. That's going to be that distance. Now, at this location, since those two forces are equal, we could simply use KQB, right, times Q, which is this charge here, divided by x squared is going to equal K, because all I'm saying here is FB equals FA. So now I've written out what FB is. It's KQB times Q divided by x squared. And this comes from the equation force equals KQQ all over r squared. And there's my r, it's x. Here it is. So then this next one would be KQA Q times, or sorry, divided by 021 plus x squared. Now we can get down to a little bit of algebra. The k's cancel out, the q's cancel out. Let's do a cross multiply and see what we get here. We're going to get QB multiplied by 021 plus x squared is going to equal QA times x squared. Now let's expand. If you remember from math, a plus b squared is going to equal a squared plus 2ab plus b squared. I'm going to apply that to here. So that's going to be QB times 0.21 squared plus 2 times 0.21 times x plus x squared. That's all going to equal QA x squared. Now, we can multiply through, and I'm going to reverse the order. So I'm going to go, now at the same time that I do that, I'm going to bring this term over to the left of this equation. So I have, in terms of the x squared, here's my x squared term, and it's multiplied by QB, so I've got QB minus QA times x squared. Okay, now I'm going to go to this term here in the middle, and that's going to be plus 2 times 0.21 QBX. That's the middle term, and now the last term plus QB times 0.21 squared, and that's all going to equal 0. Now I'm going to switch colors here. That is my A term in terms of a quadratic. This is my B term, and this is actually wrong. The whole thing is my C term. Now, what are QA and QB? Well, those were in the question. QA is 3.3 microcoulombs. Now, by the way, that's positive, but in this case, I don't need to worry about positives and negatives because I'm already considering that with my directions of the forces here being opposite. So I've already taken account my directions. All I'd like to do now is figure out what A, B, and C are. So B was, geez, I forgot now, 3.3 and 2. There we go. Okay, so what's, now wait a minute, B was 2, right, 2 minus 3.3, there, gotta get that straight. 2, change colors, 2 minus 3.3. So we've got a negative 1.3 microcoulombs here. And for this one, let's work it out here. Trusty RPN, and we go 2, enter 0.21 times, and QB is 2EE6 negative times. Now we're going to get 8.4 times 10 to the negative 7 for this one. And by the way, this is negative 1.3 times 10 to the negative 6. And C is 2ee6 negative, enter 0.21 squared times, and that I'm going to get a value of 8.82 times 10 to the power of negative 8. So now I have my values. Let's now store this into C. Let's store 8.4 10 to the negative 7 into B. And let's store negative, or I should say 1.3 negative EE 6 negative, and let's store that into A. And let's use our quadratic formula solver. And we're going to get two values here. Okay? So x is going to equal either, using the quadratic formula now, which I've plugged through my calculator using A, B, and C coefficients, 0.738 or negative 0.092. Now, obviously this is wrong, and why is it wrong? Because if we go and look at the picture, a negative value for x would mean that it's on the left-hand side of charge B. So right about there. Now what would that mean if it was there? Remember, we determined that both these forces would both be acting towards the right. In fact, they are. But what's interesting is that the quadratic formula would specify that they are in fact equal, but both pointing to the right. However, if we use the positive root, which we calculated, which turned out to be 0.738 for x, then that in fact does also produce a location where the two forces are equal, but also in this case, more importantly, they're opposite and equal. And that is the solution. So the answer is 0.738 meters to the right of charge B is the location where the electric field is 0, or in other words, where the force on the two charges is 0. By the way, the electric field, you'll notice, would just be simply kq over r squared. The q is canceled out in this equation either way. So whether you use E or F, you're going to get the same answer. So I hope you enjoyed this problem. There was a quadratic formula to solve. By the way, just in case you haven't ever seen, quadratic formulas are of the form ax squared plus bx plus c equals 0. And you can look up the quadratic formula and how to solve that. I just used my calculator to get the answers. Okay, thanks for watching. See you next time.